Hi, grade 10s. Today we are going to continue our unit on physics, and this section is strictly focusing on speed and velocity and the difference between the two of them. We are going to be able to, by the end of this lesson, calculate speed and velocity and understand the difference between them. So, saying that, we need to continue and just remind ourselves the difference between these two. So speed is a scalar, okay, which means that it has no direction. So no north, south, east, west, up, down, left, right. It is related to distance. So what you're going to learn, and you're going to look at the formula for it, we use V to represent speed. You'll notice there's no arrow on top because it's not a vector. We use distance to calculate speed because distance is also a scalar. So basically, in regards to formulas, scalars match up with scalars, vectors match up with vectors. So speed, V, the average speed is the change in distance. So that's why it's related to distance, divided by change in time. Velocity is related to displacement. Okay, so the two of them kind of connect. Displacement is a vector, so is velocity, which means it has direction, and it's the same direction as the displacement that is occurring. Okay, so how you calculate velocity is taking the displacement of the object divided by the time that has passed. Okay, and we often do that delta D. Sometimes it'll tell you it's traveled a total displacement of 50 kilometers. But then other times it'll tell you two different, a starting point and an ending point. So D2 is always going to be your ending point, so it's your second stop. And the first one is going to be where you're starting at. So that's what the D1, D2, time 2, and time 1 stands for. So what does this look like? We're going to jump right into calculations because usually this is the best way to make sense of these things. So example 1, the above race, okay, right here, is a 5-kilometer path, which means the total distance, D, is 5.0 kilometers. But the displacement, notice I've got the arrow above it for the vector for displacement, is 4.2 kilometers east. And you're going to see me write, like I said in the last video, that direction in square brackets behind my number. This indicates the direction, and it is a requirement for any vector that you are answering a question for. So the reason the displacement is only 4.2 kilometers, you'll notice if you look in the path, there's kind of a up and a down. So it is your overall distance with direction. So calculating 40 minutes. Okay, so this is our time. We use the same time for calculating both. There is no difference between, no matter what the displacement is or what the distance is, the time it took is still 40 minutes. The only problem is, if I was to tell you that I ran a 5-kilometer race in 40 minutes, I don't usually calculate it 40 kilometers per minute. Usually our units are 5 kilometers per hour or 6 kilometers per hour. So we need our units to match up. So kilometers and hours usually go together, and meters and seconds usually go together. So depending on what the question gives you, you're going to kind of look at these two possibilities and kind of go with it. Sometimes you do have to change time into either seconds or minutes or hours. So if we need to change minutes into hours, I'm going to show you how to do this. This is a little math. So 40 minutes, I want to put it in hours. So I'm going to put what I want on the top. So I want hours. Well, how many minutes are there in an hour? There's 60 minutes in an hour. So by doing this math calculation, my units, minutes, actually cancel out. And so I go 40 times by 1 divided by 60, also known as 40 divided by 60, and I should get 0.66 repeating hours. Okay, so this is our little side step that sometimes we have to do when it comes to physics and making sure our units match up. So changing this to 0.67 hours for the time being and 0.67 hours. So calculating, write the formula. V is equal to D over T. No arrows are needed because these are scalars. So D is 5.0 kilometers divided by 0.67 hours. And I should get 7.5 kilometers per hour. And that is my speed. Velocity, put an arrow above it and to indicate that it is velocity because it's a vector, is displacement, so it has an arrow, divided by time. 4.2 kilometers. This is east. Divided by 0.67 hours. And I should get 6.3 kilometers per hour. And this direction is the same as the displacement. So this is east. And that is the difference for this example of speed versus velocity. And here's just the questions worked out in a nice typed up manner. Nothing is different about those there. So example 2. An object travels 17 meters. So this would be D. It doesn't give me a direction, so it tells me it's just distance. 0.083 minutes. So this is time. So D is 17 meters. Time is 0.083 minutes. And it says, what is its speed in meters per second? That unit right there tells me I have to change my time into seconds. Okay. So what that means, this is our little side piece again, okay? And you always want to show all your steps. So if you do make a mistake in this conversion, I can still mark your understanding on everything else. This is just a number calculation. So in order to change time, 0.083 minutes, I'm going to times it by what I call a ratio, okay? I want seconds. So that means seconds goes on top, minutes goes on the bottom. Well, what's the ratio? What do I know about seconds to minutes? Well, I know that there's 60 seconds in 1 minute. So minutes cancel out. I'm left with just seconds. So 0.083 times 60 should give me 4 point, sorry guys, seconds. And so there is my new time I'm going to end up using. So now I'm going to calculate speed. So V is equal to D over T. It is a scalar, so no arrows indicated. Also has no direction. As soon as I get speed, I know that I don't have to give direction. So 17 meters divided by 4.98 seconds equals 3.4 meters per second speed. All right, example 3. If you're getting the feel for this, pause, try it out on your own. Oh, I forgot to fix one. This should be times 10 to the power of 3. And so a rocket travels 4.00 times 10 to the 3 kilometers north. So that north tells me that this is displacement because it has direction. So 4.00 times 10 to the 3 kilometers north in 6.2 hours. So that's my time. Kilometers and hours coincide with each other. They work, so we don't have to do any time change things this time. And now I am looking for a velocity. So formula, V is equal to D over T. D is 4.00 times 10 to the 3. You can enter this into your calculator in this format. If you are not sure, send me a little message, and if I can either do a one-on-one Zoom or I might make a little video on how to type that into your calculator, but it is possible. Okay. This is kilometers north. Okay. Time is 6.2 hours, and I should get velocity to be 645 kilometers per hour north. Now, this is my time that I'm going to remind you, and I haven't reminded you yet, about significant digits. This question actually only allows me to have 2 sig digs, 1, 2, not 3. So I actually have to change this into scientific notation because I only get these 2. So I'm going to move the decimal 1, 2, 6.5 times 10 to the, moved it 2, kilometers per hour north. Okay. Example 4. A man fires a spitball west with a velocity. Okay, so there is your V, and it also tells you the direction, 22 meters per second, and this is west. If the target coworker is sitting 1.2 meters away, okay, so right off the bat, it doesn't tell you that the displacement is west, but we know that it has to be the same direction as the velocity. And if you have a velocity, therefore you should be looking for a displacement. So 1.2 meters, so this is also west. How long? This tells you time, what you're looking for. So time, how long does it take the spitball to travel between the 2 colleagues? Okay, so V, velocity, is equal to D over T. I like to put my numbers in and then do the math. Some of you are going to like to rearrange first. So what I'm going to do is I'm going to say put my numbers in, 22 meters per second west equals distance is 1.2 meters west divided by time. I cannot solve for t when it is on the bottom of a fraction. So I actually have to move this t up to the other side. And mathematically, I do this by multiplying each side by t. So if you want to just think about it, what you're doing is you're going to move the t over to this side. Okay. So 22, and I'm just going to get rid of my units temporarily so you guys can see it. Just it's a simple math question. Okay. So the reason I've moved that t is I went times by t. And what I do to one side, I do to the other. So 22 times t is equal to 1.2. I want to solve for t, so I'm going to divide by 22, divide by 22, and t should be equal to 0.055 seconds. Okay. For those of you that maybe algebra and this is not your strong point, one thing that you can do, and I don't love to do it, but it is a little mechanism that you can use, is V is equal to D divided by T. So if I'm calculating my time, I'm just going to go distance divided by V. Okay. Or you can simply just memorize or write down on your formula sheet. And with enough practice, you might just memorize it on your own, that T is equal to D over V. Okay. Example 5. During a sprint, a racer passes the 50-meter mark at 6 seconds. So this is a time. And the 100-meter mark at 11 seconds. This is also a time. So this is where we have two different times. And it's looking for what is the average speed from 50 meters to 100 meters. So this is your T1. So if this is your first time, this is your first distance. This is your second distance. This is your second time. So you are looking for speed. So I'm not looking for any direction. So V is equal to D over T. No arrows needed because they are scalars, not vectors. So I'm going from 50 meters to 100 meters. So 100 meters minus 50 meters. And 11 seconds is my second time frame, minus 6 seconds. So basically, how much distance have they traveled from 50 to 100, 50 meters, and how long did it take them? 6 seconds to 11 seconds. This is going to take them 5.0 seconds. 50 divided by 5 is 10 meters per second. Okay, check my sig digs. I actually only get 2 here, 6.0 and 50. So 10 meters per second. No direction needed because this is speed. Okay, that's all there is to it. If you have any questions or comments that you would like clarification on, please let me know right away. And I will see you for your next concept. Bye, guys.